Examples of Sigra's work. Coal seam gas in Queensland. During the period from 2001 to 2011, the coal seam gas industry was being developed in Queensland. During that period, Sigra provided the bulk of drill stem testing to prove the permeability of the resource. This involved hundreds of field tests. It also required the measurement of the gas content of coals. Sigra provided and installed reservoir monitoring systems for a number of clients. It developed a cement-grouted, testable, multi-level pressure sensing system suitable for this purpose. Sigra also undertook reserve estimates and designed production systems. Sigra have, over many years, developed stress path analysis to predict the changing permeabilities of the coal seam reservoirs due to variations in effective stress brought about by the combination of fluid pressure, coal stiffness and shrinkage as the coal gives up gas. Cut 3 and 4, Centennial Highway, Queensland. Cuts 3 and 4 are rock cuttings for a major highway in southeast Queensland. The road surface at the base of the cuttings was found to be buckling due to compression across the road. This occurred at the rate of 1 mm per day in dry weather and accelerated to 3 mm per day in wet conditions. Sigra conducted the hydrogeological testing of the site involving the installation of piezometers and pumping wells. Multiple pumping tests were undertaken and analysed by Sigra for the effects of drainage in reducing pore pressure and improving stability. Data was collected automatically from site using Sigra data acquisition systems. These could be interfaced to real-time analysis of net inflow and outflow from the slope. Pressures could be used in real-time stability analysis. Belvedere Coal Mine Exploration and Design. The mining giant Vale came to Sigra in 2010 requesting that Sigra review the work it had conducted for a major coal mine development in central Queensland. This review covered all aspects of geomechanics, gas and water. The existing information was deficient and Sigra undertook a new exploration project. This involved 8 holes drilled to 1,000 metre depth that were tested for gas content, permeability and stress. This work involved hundreds of individual measurements. The design involved initial development by tunnel boring machine and pre-drainage by long hole drilling from surface. Sigra's design incorporated underground hydrofracturing to initiate drainage, thereafter enhanced by strata relaxation brought about by mining adjacent seams. Sigra's end product was a 4-seam longwall mine design. Sydney Tunnels. From 2014 to the present, Sigra has been engaged in multiple programs of work to measure the stresses in the development of new road and rail tunnels in Sydney. Associated with this work has been the development of measuring systems to determine extremely non-linear characteristics of Sydney sandstones. Kestrel Mine, Queensland. In 2014, Rio Tinto approached Sigra to prepare a drainage design for its major longwall mine in central Queensland. After examining the information gathered by other service providers, it became apparent that the range of uncertainty was too great for a final design. Sigra then conducted 2 major field campaigns to measure gas content, fluid pressure, permeability, and geomechanical parameters. The results of these is a much greater level of certainty for the mine owner and a more robust drainage design. Liang Tang Tunnel, Hong Kong. In 2016, VSL Infra4 asked Sigra to build managed pressure drilling equipment to enable the drilling of boreholes through the concrete lining of tunnels created by a tunnel boring machine. As parts of the tunnel were in sand, the risk of piping into the holes or liquefaction of the ground around the hole due to overpressure was real. Sigra designed, manufactured and commissioned this equipment on site in under 2 months. Outburst and rock burst research for the Australian Coal Industry Research Program. In 2013, the Australian Coal Industry Research Program engaged Sigra to conduct major studies on dealing with outbursting. This involved fundamental and historical research into outbursts with view to determining how things may be improved in the industry. This report was delivered in 2015. As a sequel, Sigra have produced a second stage report on how to deal with these problems, also incorporating the rock bursts in coal. Outbursting and coal bursting is tied to coal structure. Gas pressure and diffusion rate is also important. Snowy 2 Pump Storage Hydroelectric Scheme. In 2017, a decision was made by the Australian Government to further develop the Snowy Mountains hydroelectric scheme into one of pump storage, incorporating 30 kilometres of tunnels and a major underground power generation and pumping station. Sigra were engaged to measure stress at depths to beyond 1 kilometre in metamorphic and plutonic rock. This was accomplished using the Sigra IST overcore system and by hydrojacking in fractured rock. Sigra also measured hydraulic behaviour of the rock mass using its drill stem test system. This was demonstrated to be far more useful than the Packer test used in most civil engineering work. Sigra then undertook a review of the geotechnical conditions surrounding the underground power station location that has had significant consequences for the design. South African longwall exploration and design. In 2019, Sigra South Africa undertook a major study involving field testing, right through to the design of 2 longwall mines. This addressed the issues of the effect of massive strata on powered support design. Botswana diamond mines. In 2019 and 2020, Sigra has undertaken field stress measurement for 2 diamond mines in Botswana. This work is required as part of the proposed block caving design. Longwall research into massive strata for the Australian Coal Industry Research Program. Sigra are currently engaged by the Australian Coal Industry Research Program in a study to determine which rock masses will behave in a massive manner, causing weighting problems for longwalls, and how to deal with this by preconditioning. The use of hydrofracture, blasting, and high-energy gas fracturing are being considered to precondition the rock mass.